So let's finish up Chapter 3 by discussing the section entitled Statistical Summaries that begins on page 72 of Hadley Wickham's book. We've seen geome histogram, geome bin 2D, geome bar, geome raster, and we've seen stat bin referenced a couple of times in stat bin 2D. Now, stat bin and stat bin 2D combine data into bins and count the number of observations in each bin. But what if we want a summary, statistical summary, other than just a count of the numbers of observations in each bin? So far, we've just used the default statistical transformation associated with each particular geome. Now, let's explore how stat summary bin and stat summary 2D can compute different summaries. Okay, so we're going to use a couple of examples using the diamonds data. And in these two pairs of plots, the first of the pair shows how we can count the number of diamonds in each bin, and then the second of each pair shows how we compute average price. So here we're using geome bar and we're just counting. So I don't like geome bar. We're counting the numbers of all the diamonds in each of these 1, 2, 3, 4, 5, 6, 7 color categories. The bar chart's a little misleading here because the only number we're interested in is the height of the bar. The dark spot, the colored in part of the bar doesn't mean anything. You could just simply put a line here, and then you know that in color D, your count of the number of diamonds is roughly 6,600. Okay, so that's what that does. Now, what if we want, instead of count, what if we want to know the mean of, in this case, the price? Well, within geome bar, we can use these arguments. We can say I want stat summary bin, but the function that I'm going to use is mean. And you have to say fun.y equals mean. This is the function, mean, and this is the argument that you have to name to put mean in there. Okay, so if we do that, again, we're getting a bar chart. And so here's the price. And the mean price for the D color is around 3,200. It's just the end of the bar that's relevant to the question we're asking. What is the mean price of all the diamonds in each of these color categories? For example, color I, and these are discrete. These are categories, not continuous. Continuous are numbers that continue from, there's nothing missing in between. Okay, so color I has a mean price of about $5,100. Okay, let's look at another one. Now, here we're going to plot depth, and we're going to use geome bin 2D, and we're getting rid of the NAs, the missing data, because that messes things up. And we're setting the x-axis limit is going to be between 50 and 70, and the y-axis is going to be between 50 and 70. But we're looking at depth. We're plotting depth by the table. Remember, the table was one of the measurements. The table was the little flat area on top of the diamond, if it's cut right, and the depth. And so this is a count. We're binning them. We're binning them in these little squares, and you can see that the most occur when the table is about this size, 53, the top of the diamond, the table. You can look that up in the book, and you can see what the dimensions are. The table is the top. And the depth is about, most have a depth of about 62, and where the table is about 57. Okay? So let's do that again, but this time we're going after the mean price instead of counts. So we're going to use summary 2D. And again, we're binning them, but these are the mean prices. It's counting the number. It's counting the number that. It's counting the number in these bins, and the color of the bins represent the mean value. Okay, so these are the most expensive, and strangely, these seem to be a little expensive too. I'm not sure why, because the larger the table and the depth is how big the diamond is from top to bottom. The bigger stones generally are more expensive, but I guess it's a function of other things as well. Okay, well that's it for Chapter 3. We are going to skip Chapter 4. We're not going to cover that in this class. The next video will resume with Chapter 5, which is building a plot layer by layer.